Hello, everybody. So we're getting to 18.4 today, finding the volume of one last solid, and that solid is a sphere. All right. So go ahead and copy this title, get the formula for the volume of a sphere, draw yourself a sphere, which, by the way, when you go to draw this, I'd maybe start with this little oval here and then draw a circle around it. I can do better than that. Actually, maybe start with the circle and then draw that oval in there and do a dotted to give it some actual depth. Okay, so yeah, go ahead, just do your best on that, and then we'll get into it. All right, so first thing, let's just take a look at the formula. Volume of a sphere equals 4/3 pi r cubed. All right, so that is all we need to be able to find the volume here. As you guys notice, is the radius. If we can find the radius of our sphere, which is the same thing as the radius of a circle, it goes from the center to the outside. Plug that in, type it into a calculator, and we have it. All right, before we get into one of these problems, though, I want to show you a quick clip that kind of explains how this formula is created from the formula of finding the volume of a pyramid. Okay, there's actually a connection between these things. So just take a look at this. There's no sound here, so um, I'll just kind of talk as it goes through. But yeah, take a look. This is interesting. Okay, so 4/3 pi r cubed. Okay, so there's our sphere. And what they're doing is they're dividing the sphere into a bunch of pyramids. Okay, and just a reminder, the formula to find the area of a pyramid is 1/3 area of the base times height. These are all the heights of all the pyramids. Okay, which was the radius of the sphere. Okay, so they're just substituting radius for height. Okay, and just rearranging the ratio. Okay, the next thing is the area of the base. Okay, so again, they're zooming into all of these different pyramids. All right, and they say if you were to line them up side by side, okay, so adding together all of the pyramids together. Okay, so here's a strange representation of the volume of a sphere, and you'll see this will start to make a little bit more sense. Okay, so taking out that 1/3, okay, taking out that the radius, you have all of the bases of the pyramids being added together. That's what's in the parentheses here. Okay, so all of the bases added together is the surface area of the sphere, which is 4 pi r squared. All right, we'll get into that more in the future. But the surface area is just the outside of the sphere. If you were to paint it, that would be the surface area. Okay, and this is kind of a strange idea, but they're saying basically the circumference or the area of 4 circles is equal to the surface area of the sphere. All right, kind of a strange idea. Okay, so if all of this represents the surface area, we can replace it with 4 pi r squared. Okay, that r squared combines with the r to get r cubed. They rearrange it and they get 4/3 pi r cubed for the surface area. Okay, so kind of a strange video, maybe slightly over our head in what we've learned, but I think it's really interesting to see how, yeah, it was broken up to a bunch of pyramids and adding together all of the, I guess, the volume of those pyramids would get us the sphere. Okay, so yeah, something interesting to just think about, but let's go ahead and get into this and let's try some of these problems. So let's go ahead and find the volume of this sphere. Take a second and copy this, we'll do together. Okay, so finding the volume of a sphere, let's go ahead and write out our formula. Volume equals 4/3 pi r cubed. All right, and again, all we need is the radius to be able to find the volume, and we are given it. We can see we have our segment from the center of our sphere to the edge, which is 3.7. So let's plug it in. So volume equals 4/3 pi 3.7 cubed. All right, and we literally just need to type that into our calculator. Okay, so let's go ahead and do it. All right, so 4/3, get out my fraction, so 4/3. Okay, and then moving the cursor next to it, times pi r cubed, and our radius on this one, just a reminder, was 3.7. So pi 3.7, and then to do cubed, we don't want to hit this button because this is just for squaring. We actually want to hit this one right here, and this one lets us take something to any power. So this means to the power of, and then we can say 3. Right? And let's see. Here's the big thing. You want to hit enter after that for it to actually take that power of 3 into consideration. Okay, so be careful. Make sure you're getting this. Try this on your calculator because it's really important. Make sure you're getting 212.17. We're going to round to the tenths like we always do. So it looks like that one's going to round up to a 2. So 212.2. All right, and just like before, it's in units cubed when we're finding volume. So inches cubed. Okay, and that's really it. As long as you can type this into a calculator correctly, when they give you the radius, these problems are really simple. Okay, so I'm gonna have you guys go ahead and try one of these on your own. Just be really careful. This problem is not giving us radius, it is getting us the diameter. So the first thing you need to figure out is what is the radius of the circle? And then you can go ahead and plug that in to our formula. Again, volume equals 4/3 pi r cubed. Okay, figure out the radius, plug it in, type it into a calculator, try it out. Okay, so first things first, the diameter, we know the radius is half that. So hopefully you're getting pretty good at this. It looks like that's going to be a 5.5 on this one, right? All right, so that's what we're plugging in for our radius on our formula. So 4/3 pi 5.5 cubed. All right, let's go ahead and type it into our calculator and make sure we're getting the right answer. I'm going to delete this just because sometimes it screws up, sometimes it doesn't. I'm still getting used to this calculator. So 4/3 and then pi 5.5 to the power of 3. All right, and actually that changed before I pressed enter. So I don't know why I didn't do it last time. Okay, but I'm getting 696.90. So that 9's just staying a 9. So 696.9. All right, units are feet, so feet cubed. Okay, so that's, kind of your typical simple problem. This lesson's going to get into a little bit more. So let's take a look at the next example here. Okay, this one's asking us to find the volume of the composite figure. All right, and basically all a composite figure is a figure or a solid made up of multiple shapes. And you guys can see on this one, we have half of a sphere here, half a sphere over here, and then in the center, we actually have a cylinder. All right. So when you guys go to draw this, just do your best. I would probably just start with like outlining it. So draw something like this, and then draw, the sphere. That's kind of you can maybe do it a little bit cleaner, but from there you can put on the numbers and whatnot. Do your best to draw this thing. Yeah, and I'll show you what's going on here. Okay, so yeah, basically we need to find the volume of all of these figures and then just add them together. Okay, so here's what I notice. We have half a sphere here and half a sphere here. If I were to combine those two, which by the way, those would be called hemispheres. Half a sphere is called a hemisphere. If I were to combine those, it would make a whole sphere. So basically I have a whole sphere and a cylinder. Okay, let's start by finding the volume of the sphere. Okay, so we know that the volume of a sphere is 4/3 pi r cubed. Okay, we can see the radius of this is a 2, so volume equals 4/3 pi, and then our radius is a 2 cubed. Okay, so let's go ahead and get that first. So 4/3 pi 2 cubed. So 4/3, move my cursor next to it, pi 2 to the power, messed up, to the power of 3. All right, and I'm getting a 33.51, so we're going to just round this to a 33.5. All right, so there is part of my composite figure. That takes care, just so we're all clear, that takes care of this part of my sphere as well as this other one, because if we were to combine those together, it would make a whole sphere. Okay, just by the way, if we just wanted to find half a sphere, we would then just take this and divide it by 2, right? If we just wanted to know what half a sphere was. All right, but no, we do actually have a whole sphere here. It's just kind of sliced into 2 parts. Okay, so we've taken care of those 2 things. The next thing we need to take care of is the cylinder on the inside. Okay, so this is where we have to recall, how do we find the volume of a cylinder? Okay, well, if you guys remember, it was just a really simple formula. Capital B, area of the base, times capital H, the height of the cylinder. All right. So this is going back into the first lesson of this section. Okay, but if you remember, capital B was always a formula. Okay, to find the area of the base. If we're just looking at this cylinder, remember the base of a cylinder is circle. So to find the area of the base, we have to use the formula for the area of a circle, pi r squared. Okay, and then times capital H, the height of the whole thing. Okay, and the nice thing is we have the radius of the base of this cylinder, this circular base right here of this cylinder, just to kind of show you where I'm looking. All right, we have the radius, we have the height of the cylinder, so we're good to plug this in and basically get our other part. Okay, so volume equals pi 2 squared times 5. Okay, so pi 2 squared times 5. Let's go ahead and plug it in. All right, so pi 2 squared times 5. I'm getting 62.83, so that 8's going to stay in 8. So 62.8. Right, and there are my 2 volumes that make up this entire figure. The last thing to do is to add those together. So 33.5 plus 62.8 is going to get me the volume of this entire thing. Let's see, I'm just going to grab my own calculator. So 33.5 plus 62.8 gives me 96.3. And now I'm going to put the units in, which is in feet cubed. Okay, so that's all it means when we have a composite figure. Basically, figure out what shapes it's made up of, and then use the formulas we've learned in the past to find, the volume of the whole thing, add them together. Okay, so I want to do one more with you guys, and then I'm going to have you try one. Let's find the volume of, this thing that kind of looks like an ice cream cone. Go ahead and do your best to draw it, and then we'll do that. Okay, so on this thing, here's what I notice. We have half a sphere and a cone. Okay, that's what the 2 types of solids that this thing is made up of. All right, I notice we have the radius of the sphere, so we can find that, or really it's a hemisphere, half a sphere. Okay, and then we have our cone here. Let's worry about just finding the volume of this hemisphere, of this half sphere. Okay, so first things first, let's go ahead and find the volume of an entire sphere, and then we'll divide that by 2, cut it in half to get the volume of this hemisphere. Okay, so just like before, volume equals 4/3 pi r cubed. Okay, we have the radius, it's 5, so 4/3 pi 5 cubed. All right, let's go ahead and type it in. So 4/3 times pi 5 to the power of 3. Okay, and I'm getting 523.59. Here's the thing. I know that this is an entire sphere that I'm getting right here. So the last thing I want to do is take this and divide it by 2. Okay, so I'm going to actually press this enter button. Let's see, what's the best way of doing this? I wonder, let's see, if I press enter, it's going to have that. Here's maybe the best way of doing it is taking my answer and then dividing by 2. All right, so I'm dividing this entire thing and I'm getting 261.79. So I'm going to round that 7 up to an 8. So 261.8. So 261.8. And by the way, in your notes, show yourself that then we then took this and we divided it by 2 to get this answer. Okay, so there's the volume of the hemisphere, the half sphere. Now let's find the volume of this cone. Okay, so next thing is just to recall, how do we find the volume of a cone? Okay, well, if you guys look back in your notes, or maybe you've memorized it by now, it was 1/3 area of the base times height. All right, so here's the thing. I guess the first thing is, area of the base of a cone, again, is a circle. So to find the area of a circle, it's pi r squared times capital H height. Here's the problem. We have the radius, which is not a problem. That's a good thing. But do we have the height of our cone? No, we don't. Okay, so this is one of these problems where real quick, we need to use the Pythagorean theorem to find the missing side of this right triangle. All right, so I'm going to do this real quick because, hopefully you're getting good at this. So I'm just going to go ahead and plug it into the Pythagorean theorem. I know I'm plugging 13 in for C. I'm going to plug in 5 in for A and X in for B. Okay, in my calculator, I would probably just do 13 squared minus 5 squared. Okay, I'm skipping steps we normally wouldn't, but we can do that. 13 squared minus 5 squared is going to give me 144. Okay, that's what x squared equals. So last thing to solve, take the square root of both sides. And I'm getting 12. Okay, so I just really want to show you, now that we've done this Pythagorean theorem so much, you guys can probably just do a lot of this in the calculator and figure out your missing side really quick. I don't want that to take a long time. Okay, so cool. So now we can actually plug in our numbers. So volume equals 1/3 pi r squared, the radius is 5, times the height of the cone, 12. Okay, so 1/3 pi 5 squared times 12. All right, so 1/3 pi 5 squared times 12. I'm getting 314.15. So that 5 is going to round this up to a 2. So 314.2. Okay, so there is the volume of that. Be careful, easy to think, sweet, I'm done, that's my answer. No, careful. We have to go one more step and add together these values. So 314.2 plus 261.8 is going to give us the volume of our whole thing. All right, so let's see what we get. 314.2 plus 261.8, and I'm getting 576. Okay, nice and clean. Centimeters cubed. Okay, so yeah, some of this has some review. So I'm gonna have you guys go ahead and try one of these. All right, I'm gonna have you find the volume of this, I guess, compound figure right here, just to kind of, point out what's going on here. obviously on the bottom we have a nice prism, and up on the top we have this little dome, all right, which would be a hemisphere. So you're going to have to do the same thing we did on this last problem, is find the volume of that sphere and then divide it by 2 to actually get the volume of just the hemisphere. Okay, so maybe start with that, and then after you can find the volume of this prism, add them together, and then see what you get. Okay, so the volume of my hemisphere, 4/3 pi r cubed. That's how you find the volume of the entire sphere. But then I know I'm going to take that and divide it by 2. All right, so once you realize that, the rest of this can basically be done in your calculator. The radius is 3. And then again, I'm going to divide by 2. So 4/3 pi 3 cubed. So 4/3 pi 3 to the power of 3. Okay, and then I'm going to press enter and then take the answer and divide it by 2. Okay, so I'm getting 56.54, so we'll say 56.5. Okay, so there is the volume of the hemisphere, the half sphere. The next thing we need to do is find the volume of this prism. If you guys remember, the formula for that is a area of the base times the height of the prism. Okay, taking a look at the base of this prism, I notice it's just a rectangle. And to find the area of a rectangle is just base times height. And then times the capital H height of the entire prism. All right, so the base and the height, if I'm just focusing on this rectangular, oops, sorry, I'm trying to highlight it. Okay, this rectangular base here, okay, base and height, I would consider 10 and 8. It's the base and the height of that rectangle, so 10 times 8, times the height of the entire prism. Remember, that goes from one base to the other. That's the height right there, which all of these would be the height. All right, so 4. Okay, so yeah, on this 10 times 8 times 4, I'm just going to do it in my personal calculator. Looks like I'm getting 320. Right, last thing is combining those two values and getting the volume of the whole thing. So 320 plus 56.5. And it looks like I'm getting 376.5 units centimeters cubed. Okay, cool. So yeah, that is a nice, review of this entire section. And, obviously now we know how to find the volume of a sphere. So yeah, I'll see you guys.